For the 45th problem on this first ACT practice test, given that A multiplied by the matrix 2, 6, 1, 4 is equal to the matrix x, 27, y, z for some real number A, what is x plus z equal to? So for this problem, what I'll first do is rewrite this equation down below, but I'll distribute this A into the matrix. And when you multiply a matrix by some constant, every single entry in the matrix gets multiplied by that constant. So what we end up with when multiplying A by each of these is 2A, 6A for the top row, and 1A, 4A for the bottom row. And then this is all equal to x, 27, y, and z. So for matrices to be equal, they have to be of the same degree. So these are each 2 by 2 matrices. And essentially each entry, so this is the upper left entry, this would be equal to the upper left entry in this matrix. So the upper right entry, this 6A, would be equal to the upper right entry here, this 27. And then 1A would be equal to y, and 4A would be equal to z. So with this in mind, we can come up with a few equations that will tell us what x plus z is. Now you can see from these upper left entries that 2A and x are equal. So let's write that x is equal to 2A. And we also need to know what z is. So z and 4A would be equal. So z equals 4A. And now we need to know what A is. And the only entry on this right-hand side of the equation that contains any kind of numerical value is this upper right entry here, this 27. And 27 would be equal to the 6A. So let's write that. That 27 is equal to 6A. So with this equation, we now have a way to actually figure out what A is. But our question asks, what is x plus z? So x plus z, we can just make some substitutions here. Since x is equal to 2a and z is equal to 4a, so x plus z is equal to 2a plus 4a, which is 6a. And we know that 6a is equal to 27. So in other words, x plus z would simplify to 27. So our final answer here is this letter D.